So this is part 2 of MIS chapter 6. This is the slide we ended the last one on. So let's move on to the future. So this whole purpose of using a database is to end up with what we call an application or a set of programs. And that would have things such as, we see here, data entry screens where we can enter data, interactive menus where I can look for things, how many of this product are on stock, who is scheduled, or who has more sales, whatever. Maybe we're interfacing with HTML or some other programming languages. So the IT or information technology professionals and the database administrators are the people who are creating these things, but they're being used by users throughout the organization, marketing, HR. The job title we haven't covered so far in this semester is the person in charge of designing, setting up the database, arranging for all the backups, who has security, who has password protection. All of this is up to the person called a database administrator. Now this is a pretty highly paid position. Typically, if you look at the jobs in demand or predictions for jobs in demand in the future, you'll see a lot of demand for a database administrator. And I think you can see by now that this is a very important role. In charge of the data of a company, that's pretty important. So a data warehouse, that can be a place which stores lots of data. So as we think about a data warehouse, we have to think about, like, what is the data we're looking at? Everything about students or products or orders, employees. Today in the world we're dealing with a big healthcare crisis, so data could be coming from lots of places. We're looking at data based on time. When did this data go in? Where did it come from? How accurate is it? Data warehouses can hold huge amounts of data. With this coronavirus issue, we're analyzing, where did this data come from? Is it accurate? What are we measuring? Is the measuring the same? So data warehouses are a place where we can store lots and lots and lots of data. And how do we get that data? Well, some is being entered by users. We have external data sources, government documents. We have forecasts. We have existing databases, let's say of airline travelers, passengers, locations, costs, files of all the transactions, all the purchases, all the orders, all the inventory. So there's lots and lots of places where data can be generated to fill up the data in a data warehouse. And output, what we're trying to do here, we're looking at, this is what data scientists are trying to do, is come up with what kind of patterns are we seeing? What are some trends? And so we're looking beyond just the data that's being printed out. Let's analyze it. What else should we be looking at? We want to look at historical data in large amounts. What happened last year? What happened in the past? What happened in the last time the stocks went up or went down, or whatever it is we're looking at? And so some very, very bright people with some good skills and some intuition and some creative thought have to be trying to make some well-informed business decisions. We're looking at insurance companies and stock predictions and pension funds, and so many things are going to be affected by what we find in our data. Now, data marts, they're just a little smaller version of a data warehouse, maybe by one company, or let's say a data warehouse may have all the data for the students all around the United States. Well, a data mart maybe has California Community College data or something like that. So hopefully it's faster access because it's not quite as large. Maybe it's easier to create because maybe we're only dealing with California. Hopefully less expensive. Maybe users are better targeted. Let's say we're looking at student data. Well, it's a little different at a California Community College than at all colleges, because then we have military schools and private colleges and four-year schools and grad schools. So with a slightly limited scope, it may be just a lot more relevant. So business analytics. When we looked at the jobs in demand, business analyst was one of the ones in the top 20. So these are people who are using this data, and they're using statistical methods. So they're using tools like Excel, maybe a programming language like Python, It's definitely they have to have a knowledge of statistics. That's probably one of the biggest skills. But together with some insight in business, a little bit of accounting or finance or marketing, and then they're able to help provide decision makers with the information. Like maybe we should look at this stock, or maybe we should get out of this industry or move towards that industry. Anyway, this is big, big in the job place right now. So what are we doing? We're looking at what happened, trying to make some analysis, some sensible analysis of it, hopefully providing reports, what happened over a certain amount of time, what are some things, how can we react, and then also how can we predict, based that this happened in the past, maybe we can estimate that this will happen in the future. So there's just a lot of things, and I'm sure anybody with an ounce of intelligence can see this and say, there's a lot of things in the world that data science and data analysis will be a big part of. How about finding criminals, projecting crime, projecting demand for Halloween candy in certain areas. I mean, just on and on and on. Okay, so this is the era of big data. San Diego State actually has a brand new degree, and it's called something like big data. UCSD has a brand new data science degree. So there's lots and lots and lots of data coming. So much data. And we're looking at what they call the 3 V's. How much data? There's so much data coming now. And it's in a lot of different forms. And sometimes it's structured, sometimes it's not structured. How fast is it coming? Is it fast enough? Is it too fast? So anyway, big data is something we just simply want to expose the concept. Big data, for some people watching this video, may find it a career choice. And then those are getting into marketing. Well, database marketing is huge. I've had some experience doing this myself in the past, but basically, let's say you've just bought insurance through Farmers Insurance. Well, now you're in their system. Maybe that was auto insurance, but maybe they learned that you're, let's say, 30 plus years old, and you have a spouse. Well, maybe you'll start getting some marketing for life insurance, or financial planning service, or travel, or something. So once you get in a database, what a company, an old saying is something like, it's much easier to sell a product to an existing customer and sell them more than to find a new customer. So once you get in the databases, you're going to be marketed to. And if you're the marketer, you know something about people in your database. A lot of different techniques we use. Even you buy something on Amazon, the next time you log in, they know what you bought, they know your address, and maybe they'll try to sell you something that's similar to what you bought the last time. Anyway, it's very, very, very popular today, and it's all based on data and databases, and then using some intelligent decisions along the way. So who benefits from all this? Obviously retail. What are the trends? What's maybe happening in somewhere that's a trend-setting location? How can we apply that to our area? Financial services. What kind of products are people investing in? And then on and on. Elections and manufacturing and energy. What are some good plans? Healthcare. What's working here? Maybe we can have that work there. So big data is all over the place now. So yeah, why is this happening? Well, pretty much everybody you know has got a phone. They're entering data back and forth. That data is tracked by a lot more than you think about. The popularity of social networks. Many people don't really know who actually built Facebook, but was it really Mark Zuckerberg? I ask you to do your own homework and find out who else, what organization wants all of your data entered by you with your own pictures, your own locations. That if the government asked for that, people would fight back. But if you say, here, you can do it and have fun with it, we're all doing it on our own. Think about that for a minute and then do your homework. Again, smartphones, handheld devices, they know where you are, how much you've purchased, you've been using Venmo, PayPal, email, bank accounts. There's a lot of data that's being tracked by more than we think. So some of the key terms in this chapter to wrap it up. Big data, we just covered that. Business analytics. Some terms, you'll see this word CRUD, or this acronym CRUD. Something creating, reading, updating, and deleting data. Data dictionaries, where we define them. The hierarchy, fields, records, files. Please get those understood. Fields, records, actually files or tables. Database administrators, database management system, that's the software itself. Keys and foreign keys, unique data. Logical view, we'll cover this when we have an introduction to access. The physical view, same. Object-oriented databases, I'm not going to cover that right now. Primary key or key field, that is a big part of this chapter, and you'll be quizzed on that multiple times. SQL, structured query language, the one language that all major database management systems understand today. SQL. So in a database, all the files or tables are integrated. We can link from one to another. There's engines, data definition, where we define the data, application generation, where we can actually create forms and input screens and reports, and then somebody behind the scenes administering it. So this is pretty much it. This is wrapping up Chapter 3. I hope that you enjoy it and enjoy your time with Access.